Assalamualaikum warahmatullahi wabarakatuh. So in this video, I would like to talk about this important rule here where you can see that your life is going to be made so much easier when you can apply all these rules in calculating the expected value of a random variable, so either discrete or continuous. But then the rules here are applied only if you know the value of ex beforehand. So here, if a is a constant, then if you have a right next to x here, the expected value of this is just a times with ex. And if b is a constant, then the expected value of b is just b. So therefore, if you have a linear function of x, okay, x is our random variable, then the expected value of this linear function here is going to be just a times with ex plus b. So the result here comes directly from this part here. Okay, so it comes from this. Okay, so when you combine it, so you have a linear function of x, and then the result becomes as such. Well, we have learned before that if you have ex, okay, and how do you find this mathematical expectation? Well, you can either do the summation of x with fx, or you can do integration process, okay, if x is discrete. So that's what's going on. That's the basic idea of finding the mathematical expectation of x. And we also know that, let's say if you want to find the function expected value of gx here is a function of x, what you can do is you are just going to replace this guy here at this position. So that's what you're supposed to do. And actually, this is a function of x. It is just a linear function. But because this is a linear function and we have learned that the results are as such, then we don't have to go through this process here, because there is an easy way to find the expected value of ax plus b. So here is a linear function of x, and the result here is given by this formula. So basically that's the idea. And so here what I'm going to do next is I'm just going to prove that this is indeed the result here. And let's say we have a continuous random variable x. So how can we prove that the statement given here is true? So first of all, if it is a continuous random variable, we know that we have to resort to integration process. And here, if you want to find the expected value of a function, we're just going to take the function here and put it right next to our fx. And we are going to integrate that. Okay, so this is with respect to dx. And the limit here is from the lower limit and the upper limit, which is denoted by these two values here. So what we can do next is we can expand the expression here. So you will have ax times with fx plus b times with fx dx. And of course, you can separate these two expressions here. Okay, so it becomes like this. Okay, and recognize that a here is a constant. You can take it out. Again, with the same idea, b is a constant. Take it out. Okay, and what is this thing? So, well, this part here is the definition of finding expected value of x, and this part here is going to become 1 because when you integrate the PDF from the supposed range negative infinity to infinity, the result is going to be equal to 1. So that becomes a with the definition of ex plus b times 1, and that is just a ex plus b. So we have managed to prove that this statement here is true. And If let's say x is discrete, I'm sure you can come up with a proper work to show that the result here will also be similar. So that one, I leave it to you to prove it on your own, okay? Well, let's move on to this example. Well, here is referring to example 6.4, and we're just going to solve it by making use of the rules given on page 10. So this example here on example 6.4, it's asking you to find the value of, okay, this one. Okay, so how do we find this value here? Well, so what we can do is, first of all, we can start with separating the part here. So we have e to x squared plus e1, and we recognize this as a constant. You can take it out, it becomes like this, and here the result is just going to be equal to 1. So where does this come from? Well, it comes from this this rule given here. So that's what we can do, and that's all that we can do so far. So what we can do next is we are going to find this value. What is the expected value of x squared? And there is no other simple way, I think, but you need to consider this part here. So ex squared is, you're going to sum up this function x squared multiply with fx. So you have to do that process. Okay, so then it becomes well, so this is all x, you have to square it. So you have 1 square it multiply with 1 over 6, so this is fx actually, plus 2, you square it, 1 over 6, and you have to do it for the rest of the values of x given here, and it will go back to at the end. And this is just 1 over 6, 1 squared plus 2 squared plus dot dot dot, and 6 squared. And the result here is, well, if you punch in the values into your calculator, you will see that the result is going to be 91 over 6. So we're going to use the result here and plug into this part over here, okay? So here we will have 91 over 6 plus 1, and you will get the result is 94 over 3. Okay, this is another example here. If the probability density of x, so we are giving example related to continuous random variable, so here we have x, and the PDF is given as such, so show that the result here is true. Okay, so what we can do is we can start off with the definition. So if you want to find what is EXR, what we can do is, well, you can start with the definition. So this is what you are looking to find, and according to the definition, you have to, well, have this guy multiply with fx dx, and the limit is going to be from, well, 0 to 1, because that is the range given for x. Here we will have 1, 0, xr, what is fx? 2, 1 minus x, dx. And this can be easily simplified as, well, 2 is a constant, you can take it out. X to the power of r times 1 minus x r times with this, we'll get x r plus 1 dx. Well, if you integrate this, what you will get is, well, this one is going to be r plus 1 over r plus 1 minus xr plus 2 over r plus 2, the limits from 1 and 0. So substitute 1 into x, you will have 1 over r plus 1 minus 1 over r plus 2. If you substitute 0, you will get 0, so that's it. Okay, and if you simplify these fractions you have over here, you will get well, make sure the denominator here is r plus 1, r plus 2. So over there is going to be r plus 2 minus r plus 1. Okay. So r and r over here can be cancelled out. 2 minus 1 is 1. Therefore, you will get 2, 1 over r plus 1, r plus 2. And this is exactly the same thing as given by the result over here. Okay. Right. So the next example here is asking you to use the result in A to find this value here. So, okay, so when we have this function, we can start off with simplifying the look of it. Okay, so here we have expected value of a function. This function is looking a bit complicated, but don't worry, we just simplify it, okay, to smaller chunks so that you can easily calculate the value of its mathematical expectation. So here what we have is expand this, so we will have 4x squared plus 4x plus 1. Okay, so that's the result, and we can separate all these terms here. So we have e 4x squared plus e 4x plus e1, and recognize the constants and take them out. Okay, so here we have the result as such, plus 1. Now what is ex squared? Well, again, it says you have to use the result in A. So we know that this is the general result of exr. So if you have ex squared, so r and 2, you're just going to replace 2 into the position of r. So ex2 is going to be 2 plus 1, 2 plus 2. So it becomes 3 and 4. So 12, 2 over 12, which is 1 over 6. Okay, 2, 3 times 4, 2 over 12, 1 over 6. So that's the result. So just plug in right there. 4 times with 2 over 12, or 1 over 6, plus 4. So what is ex? Ex, again, we can apply the formula here. So ex means ex to the power of 1. So 1 at the position of r, you can just substitute 1 at the position of r given here. So it becomes 2, 1 plus 1, 1 plus 2. Okay, so 2, 2 and 3. Okay, so that becomes 2, 2 and 3, 2 over 6, or 1 over 3. Okay. So just punch in all the values here into your calculator. You'll be able to get that the answer is going to be equal to 3. Okay, I think that's all for now. Thank you very much for watching.